Big welcome to everyone that joined us today. My name is Yanis and I'm here with Reverica, where I work as a principal streaming architect. And today with me, I have Asaf, and he's a staff data engineer at Unity, and they have a really interesting story to share. So, hello, Asaf, if you want to introduce yourself.
Hi guys, nice to meet you and good morning or good evening wherever you are. So I'm Asaf. I've been working for 10 years at Unity in the ads division of Unity that I will talk about it soon. And I've been working with the 5, 6 years. I worked mainly with Spark, and then in the last 3, 4 years, I'm working with Flink, and I was part of the data platform team in Unity that built our data platform. And yeah, maybe we'll wait 1 more minute to see if a bit more people join, and then I will start it. I see that.
Yeah, and basically, I also heard about all the cool things that Unity is doing at Flink Forward. And they also told me, like, okay, we are using Flink and we have Paimon. Like, what? Wait, what? What are your use cases there? And we started talking. I'm like, oh, this is so amazing. And you need to share the story. And so here we are today. And I think that
Yes,
probably,
we actually met in your Flus presentation in Flink Forward, and then I asked you a few questions about Flus and payment, and yeah, it was interesting because I think we are one of the few companies in Europe or in the US that are really using payment in production. It's pretty popular in China and in the East, but I'm not sure if there are many companies that use it in such a big scale in production.
yeah, and
In
especially when I heard about your scale, I was like, whoa, because I think everyone knows Unity, but they also know it as a game engine. So I think quite a few people will be quite surprised about the things you're doing there. And I think we can slowly also start with the presentation, if it's
Yes,
okay with you, to start setting
sure,
the.
sure. Let's start. Definitely. So I'm Asaf, as I said, I'm a staff data engineer, and Nikolai was supposed to be here with me, but he's not feeling well. I mean, he's one of our core developer for the data platform, a very strong data developer, Java developer that built it. But I will be able to talk about most of it by myself. So we are going to talk in a few words about what is Unity, and a teaser is not only a game engine, about our data scale overview, and then why Flink, why Apache Paimon, and a little bit about our system. So let's start. So I guess that most of you probably know Unity as like a cross-platform game engine. It was founded in 2005, 20 years ago, actually here in Copenhagen. I'm from Copenhagen, by the way. And this day is like a very big American corporation with many offices across the world. And Unity has like two main divisions. The first one is the known one, is the game engine. As I mentioned, it's a platform to develop games that you can publish to iPhone, Android, PC, Mac, PlayStation, whatever. And it's a very, very popular one. I think that more than 80% of the games in the App Store in Google Play were developed on Unity. But the second one is like the ads division that, if I would describe it in a sentence, is how to make your game a business, how to grow your game and how to make money out of your game. And the ads division is actually divided by, I mean, there are three different companies. One is like the original Unity, Unity Ads, and during the time Unity acquired ironSource and Tapjoy. And I'm originally from ironSource, and we were merged in 2022. So from the data perspective, it also adds a lot of complexity because the data is coming from different sources. Unity and Tapjoy are also working with Google Cloud, ironSource with AWS, and like there are many different products. And it is a bit related to why we decided to build a data platform and to organize our data. A little bit about the team that I was part of. I just moved to a different team, but in the last year I was in the data platform team, and this is our scale. We have a very, very big scale. 1 trillion new messages from few dozens of Kafka topics every day, which is 1 petabyte of new data every day, and where this data is coming from. So our SDK, the Unity SDK, is installed on more than 9 billion different devices across the world. So it means that probably here in the audience, it's installed on all of your phones. And I think, I don't know, maybe it's 90% of the devices all over the world. And the scale of an ads business is huge, because for every game that people start and every like impression, request to the server, clicks, install, like so many events that are coming from all over the world. So it's a huge data. And also today, the ads business is working in a very short latency, that every time that you are playing a game and you need to see an ad, behind the scene there is like a big competition between all the ads companies across the world. So it's also related about Flink, because we need to give a decision that is as much as close to the data that we're getting from the users, and we need to transform all of our models and our AI and the machine learning to be streaming and to get all the information as much as close to real time. For one Flink job, we are talking about, like, this is one of the biggest ones, but we have a few like this, which is like 100 billion messages per day. Our Flink state can be 6 terabyte. And if we need to backfill data, like, I don't know, last 30 days or something like that, it's even like 1.5 petabyte for like one Flink job. I guess I assume that all of the audience here know what Flink is, but is an Apache amazing project, an open source one, a framework for stream processing that is designed to process large amounts of data in real time. It can handle complex event processing, batch processing, especially in Flink 2 and above. I mean, the unification of streaming in the batch is becoming more and more strong, and it's really nice, and it is fully fault tolerant as well. I mean, I can talk a lot about it, but it's a very cool and very good product. This is a small diagram of how Flink looks like. You can get your events from everywhere, usually from real-time events. In our case, we are using Kafka as our very source engine to Flink, but then we are also using Apache Paimon to write from Flink and to read from Apache Paimon to another Flink pipeline. I will talk about it in a minute, in a second. And as I said, in Flink 2.0, which is kind of pretty new, I don't remember, maybe Yanis remember, maybe 6 months or maybe 1 year, something like that. I mean, Flink, I think, was started in 2014 or something like that, and then it was Flink 1 for many years. They worked on Flink 2, but they released it about a year ago, and there were like amazing stuff. And it's now also like a big competitor for Spark. I mean, like the traditional way of companies thinking about streaming and batch applications, if you are Googleize it or asking an AI, probably they will say, if you are working in a streaming world, go with Flink. If you're working with batch, go with Spark. But Flink is becoming more and more strong in the batch as well. So yeah, so this is about Flink. And now about Paimon. Paimon, it's another thing. So it's when we are trying to describe it very shortly, we are saying that it's like Apache Iceberg on steroids, because many people are familiar with Apache Iceberg as a table format, but not are familiar with Paimon. So the basic concepts are kind of the same, like they are Parquet files with metadata that can be stored, I mean, everywhere, but most cases like in S3 or in GCS, depends on, or in Azure if you're working on. And then there are like the metadata that describe the schemas and all the data. So it's kind of like the same like Iceberg, but so what are the differences? Paimon is much more optimized to work with stream data and also with Flink. I mean, Paimon was started as part of, like, I think they call it the Flink tables or something like that. I mean, it was started as really a part of Flink, And then it like growed and growed, and it become a different Apache project. And so what do they have? They have something that is really nice. I mean, they're working with LSM trees, with log structured merge trees, and they can compact the data, store the data while writing the files, which this is a very big difference in Iceberg. In Iceberg, for every people and company that work with Iceberg, there is like a big overhead that you need to have some kind of Iceberg manager to compact the files, to manage the snapshots, the retention, to manage the life cycles of the files. You cannot just write Iceberg for Flink or from Spark, especially not in this data scale and in streaming. You need some other process to go over your files and do some operations. And in Paimon, all the basic operations like compaction, snapshot retentions, lifecycle, and stuff like this, you don't need to do anything. You can just add it to the table configuration, and Paimon does everything. Of course, there are some use cases that it's not enough. For example, if you need to write into Paimon from different sources, you do need to add dedicated compaction and stuff like this. But for the majority of the use case, it deals with compaction, lifecycle, and all of this by itself, which is very nice. And another nice thing is that you can work with Paimon kind of like Kafka. I mean, Paimon have a concept of like a consumer ID that you can have, like, let's say, one table that 5 different Flink processes reads from the same table. So each Flink pipeline can keep, I mean, Paimon can keep the offset for each pipeline by itself. And in this way, you can switch to use Paimon instead of Kafka. And I will show it soon. And it also supports multiple simulators of writers, but this is also true for Iceberg. So like in our case, we are writing to Paimon. We have like the streaming sync from Flink to Paimon. But then if we need to run backfill and stuff like this, so we're running a Flink batch jobs to overwrite or backfill the old partitions. One big thing about Paimon, I mean, our discussion if to use Paimon or not, I mean, we talked about it, I don't know, maybe 8 months ago, something like that. And I built a data platform tool with Spark and Iceberg in my previous role in Iron Source. And we had like a long discussions in our group whether we should use Iceberg or Apache Paimon. So, and one of the reasons that I thought we should use Iceberg is because it felt more mature. There is a big community. There is a lot of information in the internet in English as well. For Paimon, as I said, like there are a lot of information in Chinese, but in English, not so much. And there is no public Slack channel for Paimon yet. And for Iceberg, they are very like a big community and a lot of companies and a lot of tools that support Iceberg. But as I said, you need to also have kind of an Iceberg manager or to use some other company. There are like Rift and Tabular that was acquired by Databricks. Maybe Ververica are also doing the same, and like other companies that helps you to manage your Iceberg files. And Paimon, you don't really need it. So I think the one thing that helps us to decide that we can use Paimon is that is fully capable of generating Iceberg metadata. What does it mean? When you use Paimon, you are writing your data once, but Paimon can provide 2 kinds of metadata, the Paimon metadata and the Iceberg metadata. This means that you can read Paimon table from all the engines that supports Iceberg as well. And this was crucial for us. One reason is because our company in Unity are really, they are heavily use BigQuery. And BigQuery doesn't support Paimon. But BigQuery supports Iceberg. You can have an external tables, an Iceberg external tables from BigQuery. So it was crucial for us. And so this is about it. In the last 6 months, we also understood that the metadata that Paimon provide is not exactly one-to-one to Iceberg ones. For example, now I'm working on Starox. If you know, I'm not going to talk about it too much, but it's like another engine, let's say something like Trino, and we are trying to read the Iceberg tables from Starox because the Starox and Paimon connector is still in beta and not in GA. So we are trying to read Iceberg from Starox, and we are having some issues because the metadata that Paimon creates is not one-to-one to Iceberg. But luckily, Paimon is an open source, and Nikolai is a great Java developer, and he opened a few PRs to Paimon, and he's in a good relations with the guys from Paimon, and we're doing it, we're working on it, and we are fixing the problems. But we do have like some issues like that towards thing. And I guess this is everyone knows. I mean, before our data platform thing in Unity, we are working with BigQuery, as I said, and we are really tight on BigQuery. And I think one of these reasons that many companies are working with like differentiation of the storage and the query engines, like to keep the storage somewhere in S3 and GCS in some table format, Iceberg, Paimon, whatever, and then use whatever you want to read from this data. In our case, it's Spark, BigQuery, Trino, Flink, and now Starox, Druid, Ray, and many different technologies. Flair framework. So this is about Flink and Paimon. By the way, if I don't know how questions are working here, Yanis, should we take them in the end, or how does it usually
Let's
work?
let's go in the end with everything. For now,
Okay,
there is one, but so we can take everything in the end.
all right, we'll take them in the end. I see one question. Okay, so now the Flair framework. So what happened? I mean, in the last, I think, 3 or 4 years, we had different teams across Unity that are using Flink. But each team tried to use Flink by itself to create like a Flink application, to deploy it in Kubernetes, on GKE in our case, also on EKS in AWS, to write, to use the Java API usually. And like, it was very, you need to be a good Java developer, and also to know how to create permissions for our GCS buckets and Google, and how to add the monitoring to it and alerts to it. So like there is a big overhead for every team that wants to create Flink applications in production. And of course, there are many repetitive things. Like enrichment, for example, in our ads business, for example, we want to enrich the data from the Google Play and the App Store and from other companies. And I don't know, some simple thing like converting IP to country. So many different teams just wrote the same UDFs everywhere. And then it was decided to unify it and to create one data platform that everyone can use, and that it will be much easier to use even if you are not a Java developer and you are not very much experienced with Flink. Then we decided to build our platform and to explore mainly the Flink SQL API to the users. And then the users will be able, as I wrote here, to focus on the business logic, and our team handle everything else, the deployment, resources, observability, alerts, permissions, etc., etc. And I think it's pretty clear why we chose the SQL, and Flink SQL is well known. And I mean, SQL in general is well known, and the Flink SQL is pretty similar to other SQL standards. And if something is missing in the SQL logic, you can create a UDF in Java and to import it and just use it as a SQL function. And also, if you are working with the SQL API, so it's very easy to do like the stream batch unification, because you just write the logic once, and then you just change the dates that you are run on, or you change the source if it's a bounded source or unbounded source. In Flink 2 point something, you just know if to run it as a batch or a streaming mode. I mean, if it's a bounded source with a start and an end, so Flink just has much better optimizations and like execution plan for it. But you don't really need to touch the code. So it's really nice. I just talked about it. It has also another cool things like the auto optimization and the planner. If you are writing Java and you're not very experienced with Java, like me, I'm not very experienced with Java, you can do much more mistakes than just writing in SQL and then give Flink to handle everything. So this is about Flink SQL, and in our platform, it was also very important for us to create a nice developer experience. So our production pipeline are running on Kubernetes, on GKE, but you can also work locally, either on a Docker environment, or even like if you're working with the IntelliJ or with VS Code, they also have like plugins to Flink, and you can just run them on your laptop without anything. And we also have a Flink session cluster that you can submit your pipelines to a session cluster to test them on a real data or some sampling of our production data, and to see that everything is working before going to production. So how our data architecture kind of look like is this is one of the typical ones, and it maybe explains a bit more how do we use Paimon. So our source is Kafka, as I said, and then we are working with kind of medallion architecture, like with L0, L1, L2 schemas, or brown, silver, gold, or ODS, DWS, DWD. Like there are many different namings about it. But in general, the way we are working is that we are reading from Kafka, from Flink to Kafka, and then we are writing the data to Paimon without any manipulations. We are just taking Kafka, writing to Paimon. The only thing that we are doing is to add partition by date and hour, usually based on one of the timestamp fields. And then we have like a queryable Kafka that we can save for 180 days or for 1 year or for 2 years and stuff like this, and to use it for exploring the data, for backfills, and for everything that we want. So we are reading from Flink, we are writing to Paimon, and then on every checkpoint from Flink, we are doing a Google API call to BigQuery to update the metadata of Iceberg that the BigQuery external table points into it. If this is something that one of you interested about, so Nikolai created it, and it solves us an important things about the integration between BigQuery and Iceberg. So we are writing from Kafka to Paimon. And now in our main Flink job, that does all the manipulation, enrichment, everything, our source is Paimon. So as I said, this is very nice, and this is, I think, a bit more complicated to do with Iceberg. Because Paimon out of the box supports keeping the offset and having the concept of consumer group, and it works in like a seconds, minutes latency. So you can just write to Paimon and read from Paimon. And like back then, we needed to add Kafka here in between as well. And now we can just use Paimon. So we are writing from Paimon to Paimon. And then the L1 table, which is like the normalized with some transformations, with enrichments, stuff like this, is ready to be consumed by other processes, either Flink, Spark, BigQuery, as we said, and many others. Here, and as you say here, the integration with BigQuery Iceberg required 2 PRs to Apache Paimon that we did. And this was some of the things that we discovered along the way, that sometimes the Iceberg metadata is not, that Paimon creates, is not exactly compatible with Iceberg. And we have here another slide about Kafka to Kafka, which can, I mean, with Paimon, it's not recommended to do checkpoint in less than 1 minute intervals, because you don't want to create such a small files. So it's better to have at least 1 minute between every checkpoint, and then Paimon can create Parquet in okay file size. So we have a few cases when we need the data to be very, very close to real time, because we need to create some features for our ads model that is like super close to real time in seconds latency. So we are still in our platform support reading from Kafka and writing back to Kafka as well, if we want to get a seconds latency end to end. So how we are building a pipeline in Flair, in our data platform. So it's better to look at it. So here it's explained all the things that Flair supports, like plugins, operators, UDF, stuff like this. But let's see how it actually looks like. So A simple DAG in Flair is built this way. You need to define a YAML with your operators, which you always have an input and a sink. In this case, like it's super simple one. You have an input, some SQL transformation, and then you can write it back to, in this way, to the console, but you can write it to Paimon or to whatever. It's a very simple one. A more complex one can look also something like this. And we build this in kind of an Airflow syntax with these arrows, and you can have like arrays and stuff like this. So you have a YAML that defines your pipeline. And at the end of this presentation, I will show you the UI that we built for drag and drop and creating this pipeline. So after you have a YAML, what you need to do in order to go to so this one you can test locally. You can also test on the session cluster. But then if you want to go to production, what you need to do is to take this YAML, to create a PR in our production repository, and then a CI/CD deploys the jobs to Argo CD that handle everything, the permissions, the bucket creations, the service account creations on Google, of course, the Flink application. It also adds some monitoring, observability, and metrics. We just recently added an API call to open metadata. It is our data catalog and observability that you can see. And then you have, maybe I can just show it to you. Let me see where we have it. It is very nice. Then it's a I want to show it here because it's also a cool thing, I think. Yes. So it also submits an API callback to open metadata, and then we can see a lineage between here, like Kafka to Flair pipelines, to the L0 table, to another Flair pipeline, and then to the L1 table. So it's also one of the reasons that we created the data platform is to have all of these things and to have the data in one place. Yes. Putting it all together, how our data architecture look like. So we have many different sources. As we said, we are 3 companies, ironSource, Unity, Tabjet, that was merged into Unity. And each one of them, there are many different servers and different kind of producing. We have servers, we have SDKs, many different things. At the end, all of them go to Kafka. And then we have a Flair job that reads from Kafka right to Paimon to the L0 layer. Then we have another Flink job that reads from Paimon right to Paimon for the L1 layer. And this is the L2 is not correct that it's only Flair. Okay, I mean, for between the L1 to L2, there are some teams that are using Flink. Some of them use Spark. Some of them use BigQuery. Some of them use, maybe will use Starox, but can build whatever they want. So this is kind of our end-to-end system overview. And then I want to show you our UI and how it looks like, which is also very nice. So this is our UI. There are many different things here in the UI. You can see status of the production applications. Now I'm in my home and maybe the VPN is a bit slow. We can see like the applications are already running in production, and there is a link to Flink UI and to GitHub and to Argo. If you want to see the application, there is a tab here to onboard a new Kafka source. So you can create here, you can choose a proto buff from Kafka and then to use it. And I won't do it now. To add your configuration, to say what is your Kafka topic, and then to create an L0 pipeline, because as I said, we don't really need to do anything. We just select star from Kafka and rewrite it into Paimon. If I will show you how it looks like. So if I'm going to an L0 pipeline, so it has some many like Flink configurations that people don't really need to care about. And then the core of the job is actually this one. It's like select star and adding two partition fields, partition date, partition hour. So this is our L0 pipeline. And then we have the pipeline builder, which is pretty cool, I think. This is the way to create this YAML, which looks like a bit of an ugly YAML, but if you create it, or if I will show you how the L1 pipeline looks like with all the logic. So it looks like something like this, you see? It's like long and not so nice. But if you are using the pipeline builder, it's much more nice. So we can start with Paimon input, that we can add data source here. It's auto-discovered all our tables. I can go to L0 table and to say I want to read from action table. I just need to add here the parallelism of the Flink operator, let's say 10 for now. Then I drag and drop. And now I can use enrichment to add all our enrichments, processors, whatever we need. But for the demo, let's say I'm using the SQL processor. I have here also an autofill for the fields. I don't know which field it has. Let's say publisher app ID and offer bid. I don't know. We can also add configurations here. There are suggested enrichments. And we also have our UDFs here. You can see we need to improve our UI a little bit, but we have all the UDFs available. And then we can write, let's say, to Paimon output, to define the table name here, to dataset, to add glossary for the fields. And also it's still in progress, this UI, but it already looks pretty good. And I can run test. When I will do the test, it will say to me, I'm going to change your name to something blah blah test, so you don't override some production one. It will change the consumer ID. As I said, like the consumer is same as consumer group in Kafka. It will give me some ID, so I want, if I'm reading from a production stream, I want to affect some production pipeline. And instead of really writing to Paimon, it will just try to Elasticsearch output. So I will be able just to see the rows that I want. Now what happens behind the scenes, it creates the Flair YAML and it's submitted on a Flink session cluster. It is always live. Now it should take a few seconds and should present the results here. Let's give it a few seconds. As I said, I'm working from home now with the VPN, but you can see like this. And if you're adding transformation, stuff like this, you can see your data. And now when you are ready, we are working on adding like open PR directly from here. But for now, you can just export YAML. It exports the Flair job. You download it or you copy paste. You open a PR in the repository that I showed you. You merge it and Argo deploy it to production. This is my email and also Nicola email. If there are some people here in the audience that wants to hear or ask a bit more about it, so feel free to reach out to us. And that's it about the presentation. I will stop sharing now and then we will see the questions, I think.
Man, I really don't know what to say. I mean, all this work is just amazing. I mean, Really amazing, honestly. I don't have words for it. Even the UI,
Thank
the
you,
work
thank
you
you.
you have done. How much time did you take you to create this UI? It's amazing.
Yes, actually, I mean, the UI I think is one of the best things, and we have our team leader, Yeppe. He also was a front-end developer in the past, but I think you need to give some credit to Kelso as well, that helped him to create it. The first prototype was built in one weekend, and then he improves and improves and improves it. And I agree that it looks very nice, and it helps the user to adapt this platform.
And how
And
long did it take you to build this?
the UI or the whole platform.
The UI.
I mean, I mean, I think he's working on it in the last maybe 3 months, but not in like in a full-time job. He's a really good one, and the AI helped him a lot. And our repositories was also like we're all like they were very structured at the beginning, and worked with YAMLs, and there was like a good structure of the repository that helped him to create it. But yeah, I mean, I agree that it is amazing.
Yeah. Keep up the good job there. And the
Yeah.
scale, the UI, how you collaborate with so many teams, it's amazing. So let's see now, guys. First of all, thank you all for still being here. And if you have questions, now is the great time. So we have one from George. I do love Paimon, but with the Flu's capabilities now on the table and the union read introduced by Flus, allowing for historical and real time. Right now, data and the larger support for Iceberg. Why not Iceberg? And I think the answer to that is simple, and it's basically trade-offs between latency costs, right? Because especially I think also in the Unity case, you don't have the need for for so low latencies, like minute level latency is okay, which means that deploying things like Flux or Kafka, even Kafka, for example, can be it's just costly infrastructure you don't need. Paimon is a low-cost streaming solution.
Yeah.
Uh,
I mean, I can add to it that I think that maybe if we would start from scratch, we would consider replacing Kafka with Flux, maybe in at least some part of our system. But
you know,
as Yanis said, I mean, Paymon is just a table format. It's not a service. You don't need a server behind it. It's it doesn't really require anything. It's cost zero. There is no DevOps overhead.
yeah.
And yeah.
And you know, I'm biased, so I have to say it. So you still have time to reconsider and think about Flair. You know, I
Yeah.
have to say it's part of the job.
No, we actually, I mean, we like choosing the very mm, latest technologies. I mean, I think we were one of the first adoptions of Flink, maybe 4 years ago. We are one of the first adoptions of Paimon, and
And also,
yes, we definitely
if I noticed, also Starbucks, right?
also Starbucks. Yes,
And
yes.
so the next one is Flink SQL is very easy, but it doesn't support everything that the low-level APIs provide. How do you overcome that? Basically, this is my view. Flink SQL and UDFs are pretty great for most of use cases. And I think now also Flink 2.x introduced the polymorphic table value functions. I think it was called something like that. So you can get
Uh,
benefits with the low level APIs also. However, when I see the syntax, I still think that the data stream API is also better. So we'll see about the adoption there. I don't know. What are your thoughts on this?
so first of all, I also, I mean, maybe he asked it before I showed the UDFs that if something is missing in Flink SQL, you can add a UDF in Java and to add it to Flink. I can show you. Let's really see it. So, for example, this is a pipeline here, and the core of the pipeline is a SQL query. But then, when some things are missing, even if it's simple things like connection type normalizer, this is a UDF in Java that we wrote in Java, and we just import it here. So you can add some things in Java and to import it in SQL in a very native way. And behind the thing, this one is a pretty simple one. It's just so, like I don't know, like it's a Java code, and it does like a simple things like I don't know if it's a Bluetooth or Bluetooth, it say it's Bluetooth, and if it's a Ethernet wired cable LAN, it says Ethernet. This is a simple UDF, but you can write it if it's missing, and also you can here we support not just a SQL processor, but also like a Java ones or even Python ones. And you can also add things like that, like enrichments that Flink can read and write back some things to you. So this is the way we solved it. I mean, I hope it answers the questions, but this is the way, and it's going to be improved now. I think, as Yannis said, in Flink 2, I think 2.1 or something. They introduced the async function UDFs mode, something like that, and then many things that we are doing here, like for example, creating a UDF that, like a UDF that can create an API call and take it back and add it to your result. So they added it even more natively to SQL. So I think the Flink project is going to this direction to invest more and more in Flink SQL. But when things are not supported, we are using UDFs. And if we have a very special use case, we can just create a Flink application in Java. But so far, it works fine.
And yes, Amit, the presentation will also go live on YouTube tomorrow. And his question is also when schema handling between Iceberg and Paimon was have some issues. How you handle that?
So it's a good question. Let's see here. I mean, for this, maybe I need Nikolai. But there were two things at the first that this was one of this one. And I guess this one. So this was one. This is Nikolai. So he opened the PR here. There was a field ID missing for Iceberg compatible main first Avro schema. We found out this issue with BigQuery. When we tried to read the Iceberg one from BigQuery, it was, you see, almost, I don't know, 8 months ago. And we couldn't read it from BigQuery. It took some time to understand it, to debug it. Then we opened the Iceberg file and the Paimon Iceberg file, and we saw the difference. And I think it was not a big code change, but again, I'm not very familiar with Java. But this is one example. Another example is that we need to change the commit callback order. Nikolai here explained why. So as you can see, Nikolai opened it on November 13, and on November 21, it was merged. And also here, it was, I don't know, maybe July 10, and then July 31, it was merged. So the payment team so far are really open to help, and they are responsive. And we now have another issue, as I said, with Starox, that if you want to write from Paimon to an Iceberg restaurant catalog like Polaris, it doesn't write all the files. For example, it didn't write the parent snapshot ID in the Iceberg metadata, but this was fixed in Paimon 4.1. This is the very latest version of Paimon. Someone else opened this PR, and it was just merged to Paimon 4.1. That maybe even didn't officially release, but we like took it, we built the image of our own. Maybe I'm not saying correctly all the versions, but like in one of the latest versions. And then we found another small issue that let me I can try and find it. But anyway, the way we are handle it is like we are trying to open PRs to Paimon and to give back to the community and to help the Apache project. But if it takes too long, we are building our own Paimon image and we are using it while we are waiting for the Paimon guys to approve it.
Yeah. And also for my own curiosity, are you using a certain catalog with Iceberg?
Sorry,
You just mentioned Polaris, so I was just curious what catalog you're using for Iceberg.
Polaris. So I
Polaris.
mean, another thing that is very nice in Paimon, by the way, as I said, it gives you compaction, life cycles, retention, stuff like this. You also don't really need an external catalog. You can just work with the files in Paimon, and it's very nice. I mean, if you want to create from Starox or from Trino or from Flink cluster, you want to create a Paimon catalog, you just point to the bucket, the GCS or 2S3 bucket, and then you don't need anything else. But for example, now with Starox, we want to work with Iceberg because the Starox and Paimon connector is not fully available and stable. So we are using Polaris. Not yet in production. We just started it maybe a month ago, but things are moving fast in our company, and we already have a Starro cluster
And I think
and the
Polaris is
Polaris one. Yeah.
also graduating these days.
Yes.
So moving forward, because we have lots of questions here. Also for Flink hosting on Kubernetes. So how you handle the jar file thing, like with AWS Managed Flink service, we have to add all jar files and create a fat jar file. It's not clear to me the question here.
Yeah. So for me, I mean, in our case, we have a jar file of Flair of this of our abstractions, and we are reading the YAML file as a config map, not part of the jar. So we have Flair as a jar file. I don't think that it's too big. I can check in a minute. Um, but I hope it answers the questions. But we have like a jar file for Flair that doesn't change too often, by the way. So we just use it, and then we are reading the YAML file as a config map.
Mhm. So the next question now, how do you manage schema evolution in the platform?
Oh, that's a good question. So out of the box, we support. I mean, we kind of took the, if you know, the protobuf schema evaluation rule. So out of the box, we are supporting adding new columns and changing columns from int to big int or from varchar 100 to varchar 200, like where it doesn't break the past. We are just adding it out of the box. We added to our Flair, for every new pipeline, we're checking what is the Paimon output schema versus the Paimon table that is already in production. And if there are fields that we need to add, we're just adding the fields, and the order, it doesn't really matter. So you can add them wherever you want. If you want to remove fields or to rename fields, so we don't support it out of the box. We have we wrote a big documentation on how to do it. So you can stop the pipeline, connect to the table with Starox or with some Flink session cluster and just write commands. So we have some service that can do it. But usually it's pretty complicated because if you rename a field or if you drop a field, you can break all the consumer pipelines. So it's not about how to do it. It's about, I mean, in my opinion, as a data engineer, it's not a correct way to do it in most of the cases. Because if you have a table in production and we are a very big company, we are 5,000 employees, you don't know if you have consumers that reads the data. And if you will drop a column, rename a column, it can break things. If we need to do a very big changes, what we usually do, our convention is, you can see like here, I mean, here it's in a, let's see the Paimon output, how our tables looks like. I don't know, in offer one. So we are creating, the table is like, we say action V1, and like in a bidding V1, mediation SDK V1. And then if there are breaking changes, we will create a V2 table. So this is what we usually do. So it's not about how to solve it in the code. It's pretty easy in Paimon and in Iceberg because like you can do whatever you want. It supports rename, dropping, changing types, but the problem is that it breaks the consumers.
Great stuff. And so the last question, it seems, can I read from Paimon via JDBC connectors? I want to consume data in Paimon format from a different Java application. And
I
yes,
don't know.
you can do it, and also you can use the Java client if you want to just consume data from Java. But being an open table format, yes, Paimon supports all this. It also has, I think, supports also the Apache Arrow. So you might be able to also use things like ADBC, but I haven't tried it out, so I can't say for sure. But yeah, you can connect to JDBC based applications. But also, as Asaf has highlighted heavily here, there is also the Iceberg compatibility if there is a query engine that can integrate out of the box with Python.
Yeah. And I think that like looking forward, I believe that more and more engines will
Yeah.
add supports to Paimon. We can see it. Like Trino Spark already supports Paimon. Starrock supports Paimon, but not with all the features. We are very looking forward. One of the reasons that we chose Paimon, I didn't talk about it, but another very nice thing in Paimon is it supports primary key tables, and you can get a dedupe out of the box. You can just define a table with primary key, and if you write the data into the table and there is a duplicate primary key, you can choose if you want to ignore the new record, if you want to create some aggregations on top of it. It's a very strong feature of Paimon. We're already using it because I mean, if we can read from Paimon and not from Iceberg, it works. But if you want to use primary key tables and to read from Iceberg, you need to use Iceberg v3 and not Iceberg v2 because of some limitations on how it works. The way that it reads the manifest and the metadata files is different between Paimon and Iceberg and between Iceberg v2 and v3. And our problem is that BigQuery are not supported reading from Iceberg v3, only from Iceberg v2. So this is the reason why we are writing to Iceberg v2. But our goal is to write to Iceberg v3 when it will be possible from BigQuery perspective, and to try and to read Paimon directly because of its nice features.
Yeah. And I think, yeah, I mean, the merge engines in Paimon is also one of my favorite features, as you mentioned, like the duplication stuff out of the box. And I think we also discussed another feature that came in recently. I haven't tried it out, but and I think we also talking. You haven't tried it out yet. Is the incremental clustering for compaction, which seems really interesting. So,
Yes.
a follow-up question now on schema evolution. How do you manage table ownership, SLAs, etc.? Do you follow a data mesh architecture and share tables between apps and teams?
It's also a good question. So we are now I will answer it I will give a few answers. One is in general, the producers teams that are writing the data into Kafka and then to Flink are in charge of their Flink pipelines, and then the Flink pipelines are tagged by their own team. And we have, I can show it here. We, as part of our, where is it? As part of our deployment, we're creating basic Duke alerts on Grafana. And then, I don't know, let's say we are creating some alerts on Grafana for CPU, data that was not written for the last 10 minutes and stuff like this. And then we can write it both to Slack and to PagerDuty. to specific teams. So it defines here by tags during the deployment. And we're not using data mesh architecture for this, and shared tables between apps and teams. Yes, we do have shared tables between apps and teams. Usually the responsibility is for the producers team, the one that creates the pipeline, created the table. It's complicated. We have a lot of incidents as well, and sometimes you need to create a Slack channel or a war room and to add many people from many different teams to figure it out. We're trying to improve it also by using open metadata, as I said, so every table will have owner with some Slack channel, email, pager duty, on call, something like this, and at least it will be easy to understand who is responsible for it. So open metadata also should solve this thing, because every table has an owner.
So another question now came up. Can you share some technical aspects of how you optimize stream performance to be able to handle such large amounts of data at affordable costs? And I think this is also one of the beauty of Paimon. For the most part, it just works out of the box. But it's also a tricky question because it's also configurable, but it also depends on what you're doing, right? Because for example, if you're doing Kafka to L0 ingestion, right? It's stateless. And you also don't need, for example, that's the other beauty of Python. Like you don't need it manages states and you don't need to use Flink's managed memory. So you can give all this memory back to the JVM for the heap and actually leverage it. But it also depends if you're doing like append only tables, primary key tables. I don't know. Do you have some specific, let's say, performance tricks you have applied there?
So it's a good question. I think that Ron is asking also about Flink in general and not just about Paymon. And yes, I mean, what I usually do is I usually start with some pretty big machine and the big hard disk, and I'm choosing a large instance type. I'm starting the pipeline, and then I'm going both to the Flink UIs. I start with the Flink UI to see the back pressure, to see the bottlenecks, to see the flame graph in the Flink UI, to like start with like the basic thing. If I see that like all the back pressure is 10%, then I can say, okay, I can lower it down. So this is the way that I'm usually do. And we also have like Grafana dashboards for each Flink that we can see all the metrics. I mean, from CPU, memory, disks, and all of it. It's a different way for every engineer to work on, and usually in our company, we care more about stability of our pipeline than cost. Usually, like we are creating pipelines, we just want them to work, and then every quarter there is a big cost reduction project from all the teams that looking back on the pipelines and trying to locate the over provision cluster and to slow them down. By the way, our team that are building things, that building data Flair, we are very good at it. We're very good at creating pipelines. Actually, the problem, and because you ask the like at affordable cost, I mean, because it's a good question, because usually you can just create a big machine and everything will work. The problem actually comes, especially when we have a very nice platform as this one that I just showed you, that there are many different users across the company. It can be users that are not a very tech users. They care more about creating their pipeline. And then you can see that they can choose like huge instances and that maybe consume 5% of the CPU. So we're trying to also build alerts and monitoring and graphs to see over provisioned clusters. And actually the biggest problem that comes to our pipelines are coming from our enrichment services. Actually, not directly from Flink. For example, if we have a stream, as I showed you, that gets 100 or 150 billion messages per day, I don't know how much it is per second. And then if you need to take all of these messages and to send them into an API to get some information from the App Store or Google Store or from some internal APIs that we have in the company, for example, converting the device ID into some GDPR compliance device ID and stuff like this. we have a lot of issues actually in this aspect more than in Flink. I mean, Flink is very strong, and Flink together with Paimon is very strong. If you just need to read from Kafka, do simple manipulations, because we don't do. I mean, in this platform, in most of the pipelines, we are not doing aggregations, so we don't need to keep windows and stuff like this. We do have another team that are building features, and they need to look back on the 90 days or last 30 days, last 60 days to build complex features. In this case, even if the data is huge, we usually takes it. We're doing like a row by row transformations, like converting one row to another. So Flink handled it pretty well. For the complex Flink pipelines that we have in our feature platform and in the machine learning groups, it's more complex, and sometimes there are very big initiatives on how to do it. It can be a topic for another session, Yanis. We
Yeah.
can invite. We have some superstars in our company. I'm not one of them, but we have some that like are really really experts in Flink and can know how to do this kind of things.
Well, bring them in 3 weeks.
I
Okay,
will. I will.
we are on top of the hour, so thank you so
Yes.
much for sharing this. And as I said, I'm really looking forward to talk in person in 3 weeks in Copenhagen. If
Yes.
anyone is interesting,
See you.
it will be there. So thank you, everyone, and have a great rest of your day.
Thank you, guys. Thank you for joining. Thanks, Yanis, for inviting me. Bye, guys.